Hello, welcome to Knowledgeum. Friends, today I am going to talk on another process, advanced oxidation process, which is photolysis and photocatalysis. Since both the process utilizes light energy or photon for the reaction, I am taking this into one video. Before this, I've also made a video on another advanced oxidation process, which is hydrodynamic cavitation. The link is in description. You may want to check that. Now, without letting ado, let's begin knowledge hour. So photolysis equal to photon plus lysis. Photon is the light energy and lysis is breakdown. So photolysis means any process which utilizes light energy to bring about breaking down of materials is photolysis. Now in our context, we are using breakdown of organics into the waste water. Breakdown of organics into the wastewater that is being considered here in photolysis. Okay, so photolysis can take place in presence of visible light, ultraviolet light. uh, so the whole idea of any advanced oxidation process is utilizing OH radical, production of OH radicals, and utilizing it for the breakdown or treatment or mineralization of organics in the wastewater. So here also light energy is used to break down OH H2O radical water molecules into OH radicals, which can bring about the mineralization. Now photolysis can be enhanced using vacuum ultraviolet light rays, ozone and hydrogen peroxide. Now these or combination of any of these things. Now these things actually enhances the rate of production of OH radicals, which ultimately brings about the mineralization. And photocatalysis is an improvement over photolysis. So let's see what is photocatalysis. So photocatalysis equal to photon plus catalyst. Now this process utilizes light energy and a catalyst. Catalyst in any field, catalyst is those substance which increases the rate of reaction without them itself being consumed. So they themselves do not take part into the reaction, but they increases the rate of reaction. So here in our case we generally use semiconductors as catalyst, which increases the rate of reaction or rate of OH formation upon incidence of photon energy or light energy. Okay, now all the materials can be classified as conductors, semiconductors, or insulators based on the band gap energy. So see, here is a diagram. All the materials have conduction band and valence band, and there is a band gap. If this band gap is very small or nearly equal to zero, then those materials are conductors, because the conduction band and valence band will be very near to each other. Electrons in the valence band can easily transfer into the conduction band, so those are conductors. If there's some sufficient band gap is there, then those are semiconductors. And if this band gap is too large, such that the electrons from valence band cannot transfer into conduction band, then those materials are insulators. Okay, so this is how these materials are different. And in photocatalyst we use semiconductors as catalyst generally. A lot of semiconductors have been worked upon, like platinum, titanium, zinc, bismuth. Then now there is also concept of nanocomposites are there. A lot of nanocomposites have also been worked upon to in photocatalysis, to bring about more efficient processes. Okay, so see, this is the incident light. This light source can be natural sunlight or any artificial light source. When the energy of this incident light is equal to or greater than the band gap energy of semiconductor, then the electrons in the valence band will get transferred into the conduction band. Okay, when the energy of this incident light is equal to or greater than the band gap energy of this semiconductor, then electrons in the valence band will get transferred into conduction band, leaving behind holes in valence band. Now these holes can bring about oxidation. These electrons can bring about reduction. Now depending on the redox potential of the organics in the wastewater, as well as the position of conduction band and valence band, either only oxidation will take place or only reduction will take place, or both can take place and neither can also take place, depending on the position of redox potential of organics in the wastewater, as well as the position of conduction band and valence band. Okay, so this is about photocatalysis. Now photocatalysis is generally considered economic efficient and green technology, because see, the cost incurred in this process compared to other processes are generally less, as well as there's no sludge production, so further sludge treatment and handling costs are also reduced, so it is in a way economical process, also a green process. Now, operational parameters in photocatalysis is semiconductor concentration. So the whole photocatalysis can either be a homogeneous process or a heterogeneous process. In homogeneous process, the catalyst as well as the reactants are in the same phase, which can be solid, liquid, or gas. And in heterogeneous process, the catalyst and the reactants are in different phase. Okay, now another operational parameter is light intensity, the light which is incident, which can be either be natural or artificial. Its intensity also affects the efficiency of process. Temperature also affects the efficiency of process. Upon recombination of electron and hole pairs, generally temperature increases, so this also actually affects the efficiency of photocatalysis. And then pH also affects the efficiency of overall photocatalysis process. So recent development in photocatalysis is doping of metals and non-metals. Actually, doping of metals and non-metals in semiconductor reduces the band gap. So band gap energy is reduced. So efficiency of that semiconductor increases. Also, I just told you about nanocomposites. A lot of work is also being done on nanocomposite. Different nanocomposites are being researched upon, which can be highly efficient in this photocatalysis process. Then visible light driven semiconductors are being worked upon, because see, the sunlight which we are receiving, the concentration or the percentage of ultraviolet rays in that sunlight is very less, so utilizing that is quite difficult. But if we can anyhow manage to utilize visible light in semiconductors for photocatalysis, then that will be a great achievement. And because we can use the visible light which is very much available everywhere, so that will be a highly efficient process. Then heterojunction of semiconductor is also being worked upon. Heterojunction of semiconductors, what it does is it reduces the recombination of electron and hole pairs, so ultimately increasing the efficiency of overall photocatalysis process. Then SPR, enhanced photocatalysis, this is surface photon resonance enhanced photocatalysis. I am not talking much upon this. I would like you to comment down below what you know about this. Even if you don't know, you can comment down below. I'll try to explain that in comment section. Now, applications of photocatalysis, a lot of work has been done on dye or textile wastewater treatment, on pharmaceutical wastewater treatment, recalcitrant compound and complex mixture of wastewaters. So ultimately, the goal of photocatalysis is to reduce the concentration of organics in wastewater into desirable norms. This can either photocatalysis can either be used as a pre-treatment technology, reducing the recalcitrant compounds into comparatively degradable form, which will get degraded in the wastewater treatment, conventional wastewater treatment, or this can also be used in combination with different technologies uh, overall to bring down the organics in the wastewater into desirable norm, to reduce or do the mineralization of highly complex organics. Okay. So this is all I wanted to talk about photolysis, photocatalysis. Hope you liked it. If yes, please click on that like button and subscribe. Do let me know if you want me to make any more similar videos, or if you have any, you would like me to make any video on a particular topic. Please do comment down below. This is me signing out. Tata, bye bye. Take care.